engineers had risked their lives to build the world's tallest bridge pillars. But now the matter of connecting them to each other had fallen on their necks. During the construction of the world's tallest mixed-wire duct bridge in France, engineers were now stuck in a big problem. They had to put built-up road sections on them. The weight of one road section between the two pillars was equal to that of 25 locomotive engines. And there were a total of 8 such sections. There was no crane in the world that could lift a 5,000-ton weight to a height of 800 feet. If the crane is placed on top of the two pillars and the road section is pulled, the pillars will easily collapse inward due to their height. The higher the pillar, the weaker its top will be. This problem was no less than a nightmare for the construction team. Due to this problem, there was a delay in the construction of the mixed-wire duct, and every passing day, the construction company was fined $30,000. The mixed-wire duct in France is the world's tallest bridge, which was built in 2004 at a cost of €394 million. Standing at an altitude of 1,125 feet from the ground, it is a wonder of the world of engineering. This bridge, 45 feet higher than the Eiffel Tower, is so high that it is often seen floating in the clouds. The engineering company that had the courage to build this bridge was actually stuck with this project. In these valleys of France, landslides and stormy winds of 130 kilometers per hour were pushing their work towards the impossible with difficulty. Such a high 4-lane highway had never been built before, nor has anyone dared to build it until today. Because everyone knows that the mixed-wire duct had not only crossed the engineering limits, but had also crushed them. On the other hand, the French government was forced to build this bridge. In the 1980s, the French government was very upset with tourists from France to Spain. Especially during the holiday season, this traffic passed through all the cities and the roads of every city were jammed. Especially the city of Millau. This city is located in the middle of the mountains at a depth of 1,500 feet. The traffic coming from northern France had to get off the zigzag road first, and then have to climb up again. On the one hand, this zigzag journey would take hours, and on the other hand, traffic jams in Millau City would take at least 6 hours separately. Therefore, to facilitate tourists, the French government decided to build a motorway from Paris to Spain. The motorway could have been built straight from Paris to Millau, but there was a dead end in Millau, a mountain at an altitude of 1,500 feet, and the Tan River flowing through the middle. There was only one way to bypass this complicated condition: that the bridge should be built as high as the mountain. But it was easy to say, but almost impossible to do, because in the 1980s, when this plan was being made, the world's highest bridge at that time was the Golden Gate Bridge of California. First, it was a suspension bridge, and second, the height of the road from the surface of the water was only 250 feet, that is, 6 times less than the mountains of Millau. Seeing this, many experts said that the bridge could not be built on Millau. And even if such a high bridge is built, it will be like inviting a very big accident. For many years, this dream of building a bridge was just a dream. But finally, when the traffic jams increased to the limit, the French government had no option but to drink this bitter drink. From design to the construction of the bridge, the engineering team had to face 3 most difficult challenges. First, to build the world's highest bridge pillars, that too on the slopes of the mountains. Second, to build a 36,000-ton 4-lane highway on it. And third, to build steel pylons on the bridge. Each steel pylon was 2 times heavier than the Airbus A380. And most importantly, all these tasks had to take them hundreds of feet above the ground. For this work, the world's best architect, Lord Norman Foster, was hired. He had already made his name in the design of bridges in the world. His job was to design a bridge that was as delicate as a butterfly. But this butterfly could bear thousands of tons of weight even in strong winds. Even a small mistake in this design can cause a disaster, 2 years later, Lord Norman Foster's design was on the drawing board that his reputation was hit by a big shock. A few years ago, he had also designed London's famous Millennium Footbridge. In the year 2000, when this bridge was opened to the public, this bridge began to swing badly only because of the movement of humans. There was a very big but hidden drawback in its design. The bridge had to be closed again for 1.5 years, which cost an extra £50 lakh for repair. If such a design flaw was found in a wire duct 15 times higher than the Millennium Bridge, then it would be difficult to guess the destruction. After years of hard work, Foster had presented a magnificent design. A total of 7 pillars were designed on the bridge, and the road above it would be in a curved shape. But the problem was that the height of pillar number 2 would be the highest, while the other 6 pillars would be on the slope. The only problem was that this unique design had to be taken out of the paper and not changed in reality. The construction team who had the courage to build this bridge were given a deadline of only 4 years. After the deadline, the fine for each day was set at $30,000, i.e. a fine of approximately 25 rupees lakhs for each passing day. In October 2001, the construction of the Millau wire duct began. This bridge was being built for 120 years. Construction began with the foundation of the pillars, but as soon as it was completed, a bad news reached the geologists. They warned that there is a fractured limestone under this area, due to which there are many empty spaces between the stones. Caves have been built in these cavities, where a unique type of bacteria lives. This bacteria called blue mold is used to make the world's most famous rock-forged thing. But the most perfect thing for the thing is not to make the foundation of the world's highest bridge. Geologists here showed the danger of landslides during drilling and excavation. Despite all these warnings, the work of laying the foundation was started, but then what happened was what was feared. There was a dramatic turn in the construction of the Millau wire duct. A dangerous landslide. This landslide covered the foundation of the first pillar with stones, but fortunately there was no damage. The construction team stabilized the cliff with cement and continued the project. Approximately 200,000 tons of heavy concrete was needed to make the 7 large pillars of the bridge, for which a factory was built on the site. This was reinforced concrete, in which 16,000 tons of steel bars were to be used. If the bridge used in the Millau wire duct is laid straight, it can cover a distance of 4,000 kilometers. That is, from Dubai to China. The architect's design had fallen into the hands of the construction team. At this point, they wondered if they had made a mistake by taking this project. The problem was that the shape of the pillars was not uniform. That is, they were not the same. Thick from below and thin from above. At one time, only a 4-meter section of pillars were made. The die was made from a heavy frame of steel, then concrete was put inside it, and then the die was removed in the next 4 meters, and then the second shape of the die was raised. It was taking a lot of time to lift and remove this 15,000-ton die again and again. This race was against time. The time given to the casting of the pillars actually took more than 6 months. But this was not the only problem with the engineering team. If the location of each pillar is not pinpointed, the road section above it will never be straight. If the bottom of the pillar is made 10 centimeters away from the ground, it will create a 6-meter difference at the top. GPS technology was used for this pinpoint accuracy. With the help of multiple satellites in the sky, the pinpoint accuracy of the pillars was found and the foundation was laid there. And GPS was used during the casting of the pillars so that the top of the pillars is exactly where it should be. Months and then years passed by. In November 2003, 7 pillars had reached their final height. The 245-meter-long pillar No. 2 had become the tallest pillar in the world. But after this success, they did not get time to relax. Because the Next stage of bridge construction was the most difficult. It was not a joke to put a 2.5-kilometer-long road section at this height. The weight of this entire road section was approximately 36,000 tons. This weighs as much as 90 Airbus A380s. During this process, even a small mistake can cost human lives and billions of dollars. Let me tell you that 34 workers lost their lives on the Brooklyn Bridge in New York. And in the 1970s, 35 workers lost their lives on the Westgate Bridge in Australia. Keeping these historical losses in mind, it was decided to build a road in steel portions on the combined duct. For this work, the Eiffel Steelworks was held hundreds of kilometers away. It was the only company at the time that had the ability to build such large sections of steel. 22 steel sections were built for the road. They were of different designs. Each section weighed 90 tons. And they were made with such accuracy that not a single hair could make a difference. Cutting and welding work was difficult. But now the challenge was to take them hundreds of kilometers away to the construction site. Routes were planned. The police were taken on board. And in the form of a convoy, road sections were sent one by one. It took a total of more than 2,000 convoys to take all these steel sections to the construction site. The plan was that all these steel sections would be welded, slid over the pillars and pushed forward, as is the case with the construction of normal bridges. But the combined duct was not normal in any way. The distance between the pillars, which are about 250 meters high, is 342 meters. If a 5-ton section is slid, then as long as it reaches from one pillar to the other, the entire section can fall down due to the lack of support in the middle. If it does not fall down, then by sliding the road sections on such high pillars, the pillars will fall one by one. This problem was on the construction team's necks. To build such bridges, a new method had to be invented. Here, a senior engineer from the construction team came up with an idea. He demonstrated that if a heavy box is placed on a weak table, and it is pushed from the ground, then the entire table will move together. But if the box is pushed up on the table, then the table will not make any difference. With the help of this law of physics, it was decided that a system should be installed on the pillars of the combined duct, which lifts the road section and pushes it forward. This will not apply the force applied by the mountain to the direct pillars. Temporary steel structures were also built at a distance of 170 meters between the pillars for this purpose, which will withstand half the weight of the road section. This new system was a kind of prototype, and there was no time to test it. The future of the world's tallest bridge was just hanging on a prototype. The day of February 26, 2003 was very important for the construction team. Today, their years of hard work had to be tested in one day. The strength of the pillars in the road section and the hydraulic ramp system installed on the pillars. All the ramps of this new system had to lift the road section at the same speed and push it forward. If there is even a slight difference in their synchronization, then all the weight will fall on one pillar, and the entire bridge can collapse. Fortunately, the hydraulic ramp system worked, and in 2 days, only the 200-meter road section was moved to pillar number 1. All this work was being done by looking at the weather. Only those 3 days were selected in which there was no chance of fast winds. The reason for this is simple. Fast winds can easily knock down bridges, especially when one side of the road section is hanging in the air without support. In 1940, the pillars of the Tacoma Narrow Suspension Bridge in Washington state were blocking the air. As a result, the entire bridge began to swing badly. After a few days of its launch, the entire bridge broke and fell into the water. As the days passed, the work of keeping the road section on the pillars was in full swing. By May 2004, the road section had been laid on both sides. Now only the upper part of the river was left. If this last section does not sit properly, then all the hard work will be multiplied by 0. There is also a road curve in this section. That is why it is very important to sit at its pinpoint. The whole of France was watching this moment on live broadcast, while the French Prime Minister himself was present at the time. The hydraulic ramp was pressed for the last time. For the first time in 4 years, the roads of the north and south sections had met each other. That too with 99.9% accuracy. After connecting the road, the 90-meter-high steel pylons had to be installed for extra support. One pylon weighed 700 tons and there were 7 such pylons. It was the first time in the world that such heavy pylons were installed at such a height. The total weight of the road of the Millau Viaduct alone is 40,000 tons. After this, a damper road was laid on top of it, which added 10,000 tons and made the total weight of the road 50,000 tons. For comparison, let me tell you that this weight is equal to the weight of 1,200 battle tanks or as much as a large cruise ship. To check its strength, 28 trucks passed over it at the same time. Surprisingly, the road section, which was designed to swing up to 50 centimeters, swung only up to 25 centimeters from the weight of all these trucks. On December 16, 2004, the Millau Viaduct was opened to the public for the first time. This was the result of the hard work of the engineering team day and night, who not only successfully constructed the world's tallest bridge, but also completed the work ahead of time and made a new record. I hope you will like and share this video of eHow channel. Thank you so much for your lovely comments. See you in the next video.